Alright, I feel that song was appropriate at the time of recording this, so um, I'm not feeling great, but I'm feeling alright, so I should be back on Thursday. This lesson is going to be a little bit of review over things that we've already covered, so we'll go through a little bit of review, we'll do a couple review problems, and then there's a couple of new topics that I want to cover. Also, if you hear me scream or yell or anything, the Blues game is also playing in the background, and it's currently like 1-1, so um, I'm kind of watching that Blues game as well. Uh, that could Everybody could be sad now, and I apologize for bringing it up. But anyway, all right. So let's get on this topic. It's called circular functions. Uh, Today, I'm going to try to be able to find the value of functions based on the unit circle, and to be able to recognize a periodic function and the cycle, the period, and the amplitude of these functions. So the first part is this whole unit circle thing, and you guys have actually seen this little picture with the x and the y and the point and sine of theta is actually equal to y over r. Cosine of theta is equal to x over r, and tangent of theta is equal to opposite over adjacent, and I'm just using that little triangle up there, so y over x. And you're going to come across maybe a few problems on your homework where the angles are kind of the old school ones. So for example, the cosine of a 120-degree angle. I saw a lot of problems on the test with you guys actually being able to draw these. This is 0, this is 90, this is 180 and 270, and it's kind of your job to figure out how to get from 0 to 120. So in this case, our angle starts at 0 and then opens up until it gets to here, and this is going to be the 120 mark. Most of the angles you guys are going to come across are 30, 60, 90, or 45, 45, 90. Here was the bigger issue on the test. This is going to be a 60-degree angle. And a lot of you are forgetting your 30, 60, and 45, 45, 90 reference triangles, which is very dangerous. That's like one of the bigger things, like which one is across from the other one. So in this case, across from the 60 is a square root of 3. Across from the 30 is 1, and across from the 90 is 2. And then when you're looking at this problem, you did move to the left on your coordinate plane, so that's a -1, and you did move up, so that's a positive square root of 3. Now after you do that, your goal is to find the cosine of this angle, which is adjacent over hypotenuse. So the cosine of 120 degrees is equal to -1/2, and it's done. You can get out your calculators to double check these. There's going to be some places where it's not asking for an exact answer, so I'll double check it with my calculator here. Cosine of 120 degrees, -0.5. Awesome thing was on the test, I saw some of you actually memorize square root of 3 over 2 and square root of 2 over 2, and just write it down, and I gave you guys full credit on the test for that, which is perfectly fine. So in this case, 330, I'm a little long on that, my bad. So 330, what you're looking for is all the way around into quadrant number 4. So starts at the x-axis, opens up, comes around. If this one is 330, The question would be, how much further did you have to go to get to 360? And in this case, this angle is a 30-degree angle. A 30-degree angle. And when you're looking at this one, same thing. It always goes back to the x-axis. I saw some people drawing it over to the y-axis. Very bad. We talked about that your triangle should either go, the line here should go up or down. So it should be a vertical line to draw your triangle. Across from the 30 is 1. Across from the 60 is square root of 3. So across from the 30 is 1. Across from the square root of, or across from the 60 is the square root of 3, and across from the 90 is the 2. This time we are doing sine. So sine of 330, sine of 330 degrees is equal to opposite over hypotenuse, which is 1/2 again. They are not all 1/2. It just so happens that both of ours here on the homework are 1/2. Negative 1/2. So I moved to the right on the square root of 3, and it's positive. But the issue was I moved down on the 1, which makes it a negative. So you need to be a little careful with that. I know some of you are probably correcting me, but since this is a recording, you look kind of silly talking to a screen. But that's fine. We all should look silly sometimes. 270 degrees. Now, here are the difficult ones. The sine of a 270 degree angle ends up directly out to the right. 270 is all the way around till it points straight down. Now, the way this works is, what you're looking at is an ordered pair here of 0, because you do not move left or right, and -1. Now today I am going to show you a little trick with these to make your life a little bit easier, but for this problem I would tell you that if you are drawing the triangle, it looks like this, and it's y, x, and r. For our problem, for this problem, the tangent of 270 degrees is going to be, and if you look over here at the things that we wrote down, tangent is y over x. So y over x, and in this case the -1 over 0. So when you write -1 over 0, this one is undefined. I saw some people write no solution down on your test, and that is not the exact same topic, so I had to take off a little bit of points for it. No solution and undefined are two kind of things. This actually has a solution. It's -1 over 0. The only problem is when you try to do -1 over 0, we can't divide by 0, which makes it a what they call an undefined solution. So that's why we always write undefined. I will also tell you after the notes today, and at any point in time, Mrs. Manny can actually hit pause if you guys are in trouble. If you want to catch up on the notes, I'm leaving you a little bit of time so you can write down these answers. But I hope to put these notes on Classroom as well, and I'll also leave them on YouTube of me talking anytime that you're feeling lonely at night about your math homework. You can click on it and you can actually hear me talk. I don't know why that would be. I mean, it would be a little strange if you did that, but that's fine. Alright, so we do have to talk about a couple things. Number one, what about coterminal angles? So if we did this with coterminal angles, what's going to end up happening? And we'll actually make it an easy one. We'll do sine of 30. Coterminal would be to add 360 to that, so sine of 390. I saw some of you adding 180 to that. 180 is not a full spin around a circle, so those aren't coterminal angles. And I'll actually do one more. So these, let's do 360 plus 390, and then that should put us at the sine of 750. Alright, so, and this is kind of more just so you guys can actually see what's happening with this, because here in a second we're going to kind of talk about why we learned some of this stuff. So the sine of 30 degrees, pretty easy triangle to draw. It's kind of right out there. It's a 30-degree triangle. It's 1, opposite of 1, it's square root of 3, and it's 2. And what you should say, sine of 30 degrees, sine of 30 degrees is equal to 1/2. Now take that in, let it soak in for a minute. So the sine of 30 is this, it's the triangle opposite of hypotenuse, 1/2, it's a 30-degree angle, nobody really questions that. Now the problem is when I do sine of 390, here is the interesting thing that happens. When you draw a coterminal angle, 390 is actually 1 time all the way around and then 30 more. So the problem becomes is when you actually type in sine of 390, or you draw the triangle over here, it's the exact same triangle as you had before. And what you actually end up with is the exact same answer, which starts to get a little, kind of a little strange. Alright, the next one that we do, that ends up happening is same triangle. This time, instead of going 1 time around for 360 and 30 more, you go 2 times around, but this number is still 30 in that little corner. So I actually drew the same picture exactly 3 times. I used the same sides of the triangle exactly 3 times. And any time that I am typing these in or solving them, I end up with the exact same answer 3 times in a row. So if you start to think about a sine of 30, type it in, 0.5 in my calculator. Sine of 390, type it in, 0.5 in my calculator. Next, sine of 750 in my calculator, 0.5 in my calculator. So it's kind of nice, and it's kind of weird that it all ends up being the exact same thing 3 times in a row. So it's one of those things where I just want you guys to be aware of that. So coterminal angles end up having this exact same sines, cosines, and tangents. Once you spin around 360 degrees, it ends up being the exact same thing. So just a little extra information. This is like bonus information. Bonus information. Because I'm awesome. So, sine of 750. Sine of 390. And sine of 30. All the same thing. Alright. Now, here's the strange problem. Now, this one looks a little strange because this is the point. The directions are going to read something like if this point is on a unit circle, what is the sine and cosine? Sine of theta and cosine of theta of this point. So we have some things to discuss. Number one, what they're actually really doing is just telling you that this ordered pair, which is not a nice ordered pair by any means, it is 3/5 to the right and 4/5 up. So this point is actually out here. 3/5 and 4/5. So they're actually telling you it's just drawing this triangle that we've already talked about. But there's a kind of a little trick. And so it went 3/5 to the left, it went 4/5 up, and then it says it's on a unit circle, and that's the key, because the unit circle, or the R value, then has to be 1. So the hypotenuse to this right triangle has to be 1 when you do it. Alright, so here is my shortcut for this, so, and you might want to make a note of this. So if the point is on a unit circle, then the point, the cosine of whatever that is the x value, and the sine of whatever this is going to be is just the y value. So it's kind of a, now I want you to remember this has to be on a unit circle to do this. So this has to be on a unit circle in order to actually do this little trick. But if it's on a unit circle, if it says the point's on a unit circle, then this trick works every time. So what this actually means is, if I'm doing this little point right here, so the point 3/5 and 4/5 looks something like that, and it's on a unit circle, then the cosine of theta is actually 3/5, and you're done. And then the sine of theta is actually equal to 4/5. And it's done. Like, you don't really need to do any work, you don't need to do this little trick. And really you can do this trick again, but it's just telling you that opposite over hypotenuse is going to be 4/5 over 1, and adjacent over hypotenuse is going to be 3/5 over 1, and that's what we got. A nice little kind of to remember this is cosine and sine start with C and S, so they come in alphabetical order. So cosine and sine come in alphabetical order, and x and y come in alphabetical order, so it kind of reminds you that cosine goes with x and sine goes with y. It's just kind of a nice little thing. Nice little shortcut for these problems. You're going to get a few of them on your worksheet today, and they really shouldn't take you that long. You just have to make sure that you are matching up the right pieces to right pieces. But I am going to underline this again because it is important. These have to be on a unit circle. That is underlined 3 times. That's like, Mr. Cole, why did you underline that 3 times? I underlined it 3 times because it's important. With a capital E. Important. There's not an E that starts important, but you guys already knew that. Alright, here's the new stuff. Okay, today we are going to start talking about things that are what we call periodic functions. Alright, and a periodic function is a function, so it passes the vertical line test. Passes vertical line test. You guys remember the vertical line test for functions? That means there are no x values that go to more than one y value. No x values that go to more than one y value. Next, we start talking about some key terminology here. So maybe a good part of the matching section of a test or a quiz that you guys will have to take next Tuesday. There are 3 key terms. Number 1, what is a cycle? A cycle is one complete pattern of the graph. Next, what is the period? The period is the horizontal length of the pattern. When does it start and repeat? And I'm actually going to add on the x-axis. So I'm actually going to add a little bit. When does it start and repeat on the x-axis? So when does the pattern start and repeat on the x-axis? That's the horizontal length of the x-axis. And next is the amplitude. So the amplitude is what is the maximum height that the cycle reaches. Now, this is from the middle. From the middle. Alright, that's the worst. Middle. From the middle. So, from the middle of the graph, where is the top of the peaks? Yeah, that's a good. This is from the middle on the y-axis. On the y-axis. Alright. Give you a second to kind of catch up. So far we're on the second intermission of the game, and it's still 1-1. So far Mr. Pole is still in a decent, good mood. Alright, so here's my example for you, and we're going to add some things to this. Okay, so let's start with cycle first. How do you recognize a cycle? A cycle is recognized by picking on a point, and I would say a very obvious point. So for example, they picked on the top of the hill here, and then moving left or right until you hit that same exact point. So on this point, it starts, and then it goes downhill from left to right. So as you move across here, you find the other point, and it moves downhill from left to right. So it's starting to repeat from there to there. So that is what they call a cycle. Alright, the one thing is you really just need to recognize a cycle. Alright, there's no really number that goes along with it. You just have to really recognize where the cycle is and where does it kind of start and end. Once you find where does the cycle start and end, you can start to answer the questions about the period and the amplitude. The period of the function, find the cycle on the x-axis, the start, and then find the ending of the cycle. And your period is that length on the x-axis from where it starts to end. In this case, it's 0 to 360, so you kind of know it's 360 now. Some other people are like, Mr. Cole, it's just a cycle, blah, blah, blah. Well, that's the purpose of a periodic function. It keeps going on and on. So, in all reality, this is another cycle. Now, what you notice from cycle to cycle is that the period should match. And I always tell people, if you end up with two nasty numbers, you can actually subtract those two numbers. So in this case, the 720 degrees minus the 360 degrees is equal to a 360 degree period. It's kind of nice, and if you can find the one that goes from 0 to whatever, it's nice, but sometimes you're struck and you actually have to find one that's a little different. So you might want to use this whole subtraction key to help you find like harder numbers. Always do the bigger number minus the smaller number, so that way there's no negative period. And then last but not least, we do have to talk about amplitude. Amplitude's not used very often, and I don't even know if your kind of homework tonight talks about it, but the amplitude of something starts from the center of the graph. So what that means is from the top to the bottom. So if you notice, this is from 1 to -1. So the center is at 0 on the y-axis. And the question is the amplitude is how high does this graph go up into the air to the peak of the mountains here on this one. So what is that height? And the answer is it has an amplitude of 1 unit. 1 unit. I will tell you, this is the only new stuff that we're going to be talking about today. So everything else that we've kind of went over about the kind of making the triangles on the graph, you guys have seen that before. Making the 30, 60, 90 triangles, you've seen that one before. Again, 30, 60, 90 reference triangles and all that stuff you've seen before. The only new stuff is this whole idea of the periodic function, where it's a cycle, a period, and an amplitude. Cycle is what is the pattern, when does it start, when does it end. The period is how far does that go on the x-axis, and the amplitude is how tall does it get from the middle of the graph. So from the middle of the graph, how far does it go up, how far does it go down. In this case, the amplitude of this problem is it goes up 1. It also goes down 1. So it's kind of a thing to think about. If your graph went up 10, it would also have to go down 10. So in a periodic function, the nice thing about this is the amplitude, it has to go up and down the exact same amount. So there's a lot of things that kind of, with period functions that are nice, periodic functions works nice where it repeats and it's a regular interval, so it just keeps happening over and over again. So let's look at some examples and just kind of talk about these. I'm going to give you some like quick tidbits of like what happens or what you have to keep a lookout for. So the first thing on this first example that you need to keep a lookout for is where does it repeat? So be careful with picking your points. For example, you would not want to pick this point to this point. This point goes uphill, and this point actually leads into the downhill and then flattens out. So these 2 points are not where that cycle begins, and I know probably everybody or most of you are rolling your eyes at that because you're all like, well, Mr. Cole, I wouldn't have picked those 2 anyway. I might have picked here at 0 and then the top of the hill here at 0, and I would probably agree with you. If you can always start on 0, it's nice. But you might not always be able to start at 0, so I just want to point that out. Be very careful kind of with this. So the problems are probably going to ask you for what is the period and what is the amplitude. And if you can pick nice numbers, like, well, now I know pi over 2, pi, 3 pi over 2, and 2 pi, you guys are like, these are stupid numbers. Just subtract them, alright? So the period from 0 to pi is actually, let's say, pi take away 0. So the period is pi. It's just one of those things where, and no matter what you use for this, so let's say somebody gets ambitious and wants to go from the middle of the flat part to the other middle of the flat part. If you have 3 pi over 2 and you take away 1 pi over 2, you actually get 2 pi over 2, which is 1 pi again. You will get the same answer, I promise you. If you were to go from the top of this hill to the top of this hill, 2 of those take away 1 of those is still 1 pi. So the period is always going to be the same as long as you can find the correct cycle. Next, the amplitude is a little bit harder sometimes on a lot of these. This is the top of the hill. So this is the top of the hill. This is what they call the bottom. And the question becomes is, from top to bottom it goes from 1 and it goes down to -1, so the amplitude would be 1 unit. A lot of them will be 1, but as you'll notice here in a second, some of them do kind of change and fluctuate a little bit. From here on out, it's just finding the period and amplitude of these. So the period is on this one, where does it repeat? Try to find a nice number, and this one is actually a really kind of tricky one, because if you start at 0 and you try to hit the next spot, this is not where it repeats. It goes uphill from left to right. It does not go uphill from left to right again. So that's what I was kind of telling you about. You have to make sure you pick and choose your points kind of nicely. So look a little longer at the graph. This goes uphill. So I'm looking for the next time it crosses and it goes uphill. So it would actually be this one. That's the one where it goes uphill from left to right. We did get the zeroing, so we can do pi over 3 take away 0, which is equal to pi over 3. If you wouldn't get that one, 2 pi over 3 take away pi over 3, the answer is still 1 pi over 3, so on and so forth. I'm going to abbreviate amplitude again as the amp. This one we can't tell, so I'm going to put down question mark units because it's not labeled. So there is no label on the y-axis, so you really can't tell me what it is. Alright, I chose this next one because it's actually a little bit hard for the amplitude, not the period. So the amplitude starts at 0 up top, and then it kind of goes downhill from left to right. So I'm looking for the next time that it's up high and goes back downhill. The period is 1 take away 0 on the x-axis. 1 take away 0 is 1. Now here's where the amplitude gets a little tricky, and I'm going to kind of show you a little trick how to find this. First of all, this one's a little tricky because it kind of lands in between here, 15 and 20, so what you name that number is kind of up to you. But it looks like the bottom of the hill is at 5, and the top of the hill is at 17. And you could actually call it a couple things. We'll call it 17. Now here's where it gets tricky. You really need to find the halfway point between 5 and 17. 5 and 17, 5 and 17, 5 and 17. The easiest way to find the halfway point between 5 and 17 is to add those two numbers and divide by 2. So 17 plus 5, 17 plus 5 is 22, and divided by 2 is 11. Now, this is not the answer. 11 is actually kind of the middle of the road. So 11 is the middle number. So the amplitude is actually how far is it from 11 to 17, and how far is it from 11 to 5? And that's where this problem and the amplitude get a little tricky. The amplitude is actually one of the harder ones to find. So when I'm looking at this, once I find the middle number, now I can kind of go, okay, so 17 is my bigger number, and 11's my middle, so I know that the amplitude is actually, oh, did I just break the internet? 6 units. I think I broke the internet. 6 units. Come on, Charter, don't fail me now. Sorry, I can't say Charter. Come on, Spectrum, don't fail me now. Alright. We'll go through these a little bit faster. Those are all the kind of tricks that I can think of that the book will pull on you. So the period on this one is, let's go bottom of the hill, because it's actually at 2, and that one's actually easier for me. And this one's at 4, we'll just do a little bit kind of quicker. So the bigger number is 4, smaller number is 2, 4 take away 2 is 2. Next, amplitudes are always nice when you notice that they like kind of start in the middle, and they go up and down the same, so it goes up to 1, and it goes up to 1, but it also goes down to -1. So the amplitude would be 1 unit for this one. So let's go period and amplitude. Last one is kind of tricky because everybody wants to go from 0 to 2 pi. Remember, you're looking for the one where it goes uphill from left to right. I don't know if I can grab this. Let's see if this actually works. So I'm actually, oh, Mr. Columbia, amazing. No, hold on. Nope, that's not gonna work. Biscuits. Nope, definitely not that. Yes. No, that's not it. No, absolutely not. Oh, blue. So the question would be is where, oh, I just grabbed it. Where is the next time the graph goes uphill? And if you stop at 2 pi, it doesn't. So you actually have to go all the way out here to 4 pi. So that is the tricky part. So this would actually be 4 pi, take away 0, which is actually equal to 4 pi. Amplitude, where's the top of the hill? Where's the bottom of the hill? So it's 1 unit again. Oh, that's blue. That's what I'm missing my hand. Oh, green. 1 unit. So period and amplitude are most of the problems. The question is why do we do this at a trig chapter? And the question, or the answer is, if you look at trig functions, and you guys don't have to write this down. So if you look at trig functions, and this is a cool website. If you look at trig functions, so when we talk about these, trig functions are what we call based on a circle, the unit circle. The green one on this graph is sine, and then the blue one is cosine, and the gray one is tangent. So if you're looking at this, trig functions, once you go around the circle one time, sine, cosine, and tangent repeat again, over and over again. So these functions, no matter what you do, if you start to graph them, as you start to go around the circle, you're always going to get the same answers over and over and over and over and over. I wonder how many times I can say over before you guys actually stop listening. You probably stopped listening about 20 minutes ago. That's night. I always say there's probably somebody on the phone in the crotch. There's probably 2 heads down, and that makes me sad. So, but I do what I can. So in all reality, we're going to talk more about this when I come back on Thursday, about these graphs and how they repeat themselves over again. But in all reality, you guys already knew that they repeat themselves over and over and over again. And that's what I kind of showed you with this coterminal angle. Sine of 30 is 1/2, sine of 390, 1/360 around. Is 1/2, sine of 750 is 1/360 around, that's 1/2 again. I do want to make a tiny note here at the end. For those of you who are still not doing well with these triangles, across from a 30 is 1. Across from a 60 is square root of 3. Across from a 90 is 2. There were a lot of you reversing these two. And then I'll do this one. That's an awesome triangle. You're getting so much better at this, Mr. Paul. This one is the 45, 45, 90 triangle, if you need it. 45, 45, 90 is 1, 1, and the square root of 2. So take a second, if you can pause the video, rewind it. Those are the triangles again. Make sure you write them down. This is a 30, 60, 90 reference triangle. And this is a 45, 45, 90 reference triangle if you need it. Reference triangle. Right now backwards, but reference triangle. Alright. Have a good day. Make sure you work on your homework. We'll check the homework when you get back, and we'll actually do a new lesson. So